Good morning to the grade 11s that's currently working from home. What we are going to do today in the maths class at school is we're going to look at general solutions where we solve trig equations without a calculator. So what does it mean if I have without a calculator instruction? It means they want me to use special angles. So currently you know that you have 30, 45 and 60 as special angles, and you know how to set that up, and you know that each one of them has an x and a y coordinate representing the adjacent and opposite side. Okay, now when you get to 90 degrees, okay, you in grade 11 need to be able to do this, and you need to know how to extend, okay? Because you did cofunctions and also negative angles, but let's first start. So I can go 30 degrees past 90. So 30 degrees past 90 is 120. I can go 45 degrees past 90. So going past there, that's 135, and I can go 60 degrees past 90, so that angle there is 150. Now each one of these points will have its own coordinates, set of coordinates, also x and y, representing the adjacent and opposite sides. Okay. Now let's compare what happens in the first quadrant and what happens in the second quadrant. So in the first quadrant, I was on the positive x side and the positive y side. In the second quadrant, I'm on the negative x side and the positive y side. Okay, that means if 30 degrees is square root 3 and 1 in my first quadrant, 30 degrees in my second quadrant, on my negative x side, will be negative 3 and 1. 45 is square root 2 and square root 2 with a positive x and a positive y. When it moves to a negative x and a positive y, it means I will have negative square root 2 and square root 2. When I look at 60 degrees past 90, on the positive x and y, I have 1 and 3. That means on the negative x, I'll have negative 1 and 3. Okay. We also taught you about negative angles, and negative angles are measured clockwise. So if I have a negative 30 degrees, I will be in my fourth quadrant. If I have a negative 45, it will be in my fourth quadrant as well, and also I can add a negative 60. Each one of these will have an x and a y coordinate representing the adjacent and opposite side. Now I need to think. When I'm in my fourth quadrant, I have a positive x but a negative y. So 30 degrees in my first quadrant was square root 3 and 1. So I'm still on my positive x side, so square root 3 stays as it is, but now I will have a negative 1. 45 will be square root 2 in my first quadrant, but in my fourth quadrant, it will be a positive x but a negative y. And 60 degrees, positive x, negative y. Right. So you need to be able to extend your special angles on your Cartesian plane in this manner. Why? Because I'm going to ask you to solve equations without using a calculator. So I'm going to give you cos theta equals square root 3 over 2. Now square root 3 over 2a over h can be in my first quadrant, but it can also be in my negative quadrant. Let's look at some examples. But before we run off too far, what do I know about the word general solution? Whenever the word general solutions is used, I know whenever I have sine theta, I will have theta equals to the reference angle plus k times 360. K is part of integers, or theta is 180 minus my reference angle plus k times 360, and k is part of integers. Okay, when I talk about cos, I know theta will be plus minus my reference angle plus k times 360. And when I talk about tan, theta will be the reference angle plus k times 180. Okay, so that's my summary for my general solutions. Right, so I have pre-written down the examples for you guys, so I'm just going to look at them. So, give the general solution of the equation without using a calculator. So if I say to you, I just want to write this down, so sine theta equals square root 3 over 2. Give the general solution for this without using a calculator. Right, so theta, I know, is going to be shift sine square root 3 over 2. Okay, but where do I find O over h that equals square root 3 over 2? So I need to go look at my Cartesian plane and find my O value. There, it's sine of 60. Okay, if I go on, I also find it where? Okay, we'll look at that just now. So, I know, but sine negative 1 square root 3 over 2 equals 60 degrees. So, general formula, theta is 60 plus k times 360. K is part of integers, or theta is 180 minus 60 plus k times 360. K is part of integers, so theta is 120 plus k times 360. Okay. Next example that we're going to do, I want to keep that table or that summary next to me. So if I say to you, give the general solution of the equations without using a calculator, and you have cos theta equals minus 2 over 2, minus square root 2 over 2. Okay, I know that theta is shift cos. Okay, I need to go and find A over h that basically fits minus square root 2 over 2. So an A value of negative 2. A value of negative 2. Here we go. And that is at where? 135. So general solution, I have theta is plus minus 135 plus k times 360, and k is part of integers. Okay, not that bad. What if I say to you, you have tan theta equal to minus square root 3. Without using a calculator, give this general solution. So I know theta is shift tan minus square root 3 over 1. Why am I doing that? Because tan is O over A. So I want to go see where do I have an O value of negative 3. So O value negative 3 I will find here. I'm working in a clockwise, so that is negative 60. So my general solution is negative 60, and I am busy with tan, so k times 180. Alright, okay, so as your textbook doesn't have any examples, or in the homework there's no examples in your textbook to do these questions without using a calculator. So all of these questions is without using a calculator. Here are 3 questions that I want you to do. So I will be giving this to the students in the class, but if you're at home, please write these down, do the questions, and it will be loaded as the memo tomorrow morning. So 3 questions for you to do. Please add that to your homework. Grade 11s, we continue with the general solutions, and today we are going to grab our calculator again and we are going to look at more challenging examples. Okay, just a general note that you need to remember that we read from left to right. Therefore, you may only move the number in front of the sine, cos, or tan, but you may not move the degree or the coefficient that is attached to the angle. You may only move this degree or coefficient after you have determined your reference angle, and with sine determined your 2 equations, and cos determined your 2 equations, and tan with 1. Okay, so we're going to look at examples of this. So if I say solve, now the word solve means determine the values of theta. It means that you are going to assign k with different values, and you're going to find the angles that lies within the certain interval that they want you to get. So to correct to 1 decimal, if 3 cos theta minus 15 is equal to minus 1,583, and theta is part of negative 180 included up to 180 included. Right. So first of all, you can breathe a sigh of relief, because that is automatically indication to you that you may use your calculator. It's not going to give me my special angles. So what am I going to do first? I'm first going to divide both sides by 3. So I will have cos theta minus 15 equals to minus 0,5276. I am not going to lose any decimal values in the middle of a question. I'm only allowed to find the answer at the end. Okay, so after I did that, what am I going to do now? Reading from left to right, I'm going to move cos from the left hand side to the right hand side. So it will become shift cos on the right hand side. Now I am busy with general solutions, and I'm busy with cos. So what do I know about general solutions and cos? My answer will be 2 equations, either plus or minus the reference angle created plus k times 360. So I'm going to have theta minus 15 equals the reference angle plus k times 360, or a theta minus 15 equals negative the reference angle plus k times 360. Okay, so there I have it. Okay, so there's my reference angle, and the minus 15 moves over and becomes a plus 15, and there is my second option, 15 minus the reference angle, and there are my two solutions. So because they said solve, I need to find possible angles that falls in between minus 180 and 180. I'm going to fill in values. Start with -1 if you have to. Start with -2, whichever you want. I did it here to save some time on this video. So if I substitute both equations with a -1, the first one gives me minus 223.2 and minus 466.8. I substituted k and I got those two values. I substituted k with 1 and I got those two values. Looking at that, that's outside, outside, that will work, that will work, that is outside, that is outside. So my only possible answers for theta is 136.8 and a minus 106.8. Okay. So if I look at another one, I will say to you, determine theta if 2 sine theta plus 20 is equal to minus 0,8654, and the instruction is to find the size of theta. They didn't say solve, so I don't have to go and do the k value substitution. Reading from left to right. The 2 is bugging me. I'm going to divide both sides by 2 without leaving or losing a decimal number. Reading from left to right, my next stumble block is sine. Move it over, it becomes shift of sine. Okay, now because we work with sine, I know that I'm going to have two possible answers. I'm just going to open it up for you. My first one is my reference angle plus k times 360. The second one is 180 minus the reference angle. Okay, so the reference angle is shift sine of negative 0,4327. That gives me minus 25,6. Now only the 20 moves over and becomes minus 20. And the same here, theta plus 20 is 180 minus the reference angle. A minus and a minus is a plus. I'm going to add those two, but then plus 20 will go over and become a minus 20. Therefore, my answer of 185,6 plus k times 360. All right. So the homework for these questions are in your textbook. Other than the homework for the special angles, I gave you those extra questions. Your homework then for tomorrow, Thursday, is exercise 7.11, number 3, 4, and 5, plus those 3 additional questions that you had to do for the special angles section. Okay.